Hi everyone. As I said, my name is Peter Souter. I'm a technical account manager at Puppet. Been working with Puppet. That's actually, I need to change that. That's now 7 years. Been at Puppet for about 2.5 now. And what does a technical account manager do? So depending on where you are, the TAM kind of goes from someone who is basically just a support ticket chaser all the way to like someone who's looking at the kind of holistic program of Puppet at a company. So looking at new features and talking to teams and kind of evangelizing a Puppet as well, which is why I'm here at something like this. So I'm really super excited to be here. I love DevOps Days. I think I went to my first DevOps Days, DevOps Days London 2014 or 13. And it's always been my ambition to speak at DevOps Days. Basically, I had a bunch of conferences that were kind of my targets of speaking at some point. So 2016 was a good year for me because I hit FOSDEM, Config Management Camp, and PuppetConf. I'm speaking at DevOps Days this year, and again in DevOps Days London in a few months' time. So I'm still on my way to try and speak at Lisa and Velocity Conf for some flavor as well. So what we're going to talk about, so we're in the security track, so we're going to talk about security, right? And I use this because this is, and the term DevSecOps and DevOpsSec and rugged DevOps and that kind of stuff, it comes up a lot. But it's kind of basically a reflection of where we are right now, which is that people are kind of going, okay, we've kind of broken down the dev and ops silos, but we're still throwing it over the wall to security now. And we've kind of heard over the last few days, especially in the breakout sessions, people are still talking about throwing it over the wall, and there's the idea of moving security left, which we're going to talk about a bit as well. So what we're going to cover, we're going to talk about what are the risks of leaking secrets. We're going to talk about how do you actually prevent leaking those secrets and how do you detect those in the future. What kind of parts of the DevOps toolchain can you use to help with detecting and fixing these leaks of secrets? And when you do detect them, how do you detect them and what can you do about it? And that's probably one of the hardest parts. So before we kind of talk about something, we have to define it. So obviously, I work for Puppet. I'm generally talking about Puppet here. Most of my examples are going to be Puppet related. But most of the stuff we're talking about is fairly tool agnostic. And it would apply for anything you're using, either a direct infrastructure as code tool, like let's say Puppet or Chef or Ansible or Salt, but also for pretty much any kind of part of infrastructure as code you're using. So maybe Terraform, maybe even just your config YAML files, whatever you're using out there. So what are secrets in IT? This is a really good definition from a talk that I'm going to link to later on. But they are small, they're radioactive, they're required. So they're small, radioactive, and they're required. So they're small. If a secret is like a PDF document or a terabyte of user data or something like that, that's less of a secret and more protected data, which is something slightly different. So they're radioactive. So there's bad consequences from it being leaked. So, for example, I've worked at places when I used to do government contracting where things like host names and IPs were classified as secrets, which, I mean, there's a big argument you can have about that kind of stuff. I probably disagree on that part because people have Nmap, people have security tools. A lot of the time, they're going to find out these IPs anyway, but that's another discussion. And yeah, they're required because if you have a secret that's not required, get rid of it. If you're using a password for something and you don't need to for some reason, then you can probably decrease the risk in your organization by just not using that secret. So how bad could it be? Hopefully, I don't have to tell you that leaking secrets and credentials is a bad idea. So here's a screenshot. This is something that it's happening less now because AWS are actually kind of proactively detecting things like this. But there's a bunch of horror stories out there, especially with the rise of Bitcoin mining. The classic one is someone pushes their dot files with AWS _access_ID up to GitHub. There's bots and tools out there that will automatically scrape GitHub and other sources for that kind of stuff. They get your AWS credentials, they lock you out, and then they start spinning up machines to mine Bitcoin or just do bad things, basically. And yeah, I mean, worst case scenario, your entire company can be destroyed by leaking a secret. And there have been recent cases of companies basically like either going bankrupt or having to be saved by other companies when this happens. So ransom, there was a recent incident where someone's laptop got taken over and the person basically stole all of their application code that they were using and then tried to ransom that. They were like, give me a bunch of money or I'm just going to release this on the internet for free. Data theft, so we just heard the talk about, things about data security. If you're keeping people's personal details and you're not protect them in the right way, and then they get released on the internet. That's also bad. You're probably going to end up either fined or maybe even in jail. Lots of customers is not a good look if you have a company and then you lose people's data. They're probably not going to use you in the future. And yeah, legal and PR fires in general. So how do you actually prevent leaks in the first place? How do you plug these holes? So the first things first, you need to clean up your infrastructure as code repos, be it one monolithic one or all the various bits you're getting information from, and you need to get rid of all your plain text passwords. So who here, don't be shy, everyone close their eyes and put their hands up. Who here has plain text secrets in the infrastructure as code right now in some form? Okay. So obviously the first thing is make sure that your code is not public at all if it's in that state, because if you have public code on GitHub, it's probably already leaked. But we're going to talk about some of the tools you can actually use to prevent this stuff. So first is a tool called TruffleHog. I'm not sure you can see that well. So what TruffleHog does is it's more generalized. It will go through your Git commits and your Git history, looking for any piece of data that's over n complexity. So basically, it'll look for things that it assumes will be IDs or passwords and things like that. So this is better. There's going to be a lot of false positives in this because you might have some random key that's not a salt or a secret that's just in there, maybe even documentation examples, and these are going to be flagged up. So this is good for kind of like the brute force method of looking for stuff in the first place. And in the screenshot you can see, this is looking through what looks like some Java code, and it's found that someone's hard-coded some AWS credentials in there, so that's bad. The second one is a tool called GittyLeaks. It's a Python package, and it's slightly more advanced because it will basically do what the last one's doing, but also grep for terms like API, password, look for the format of private keys and things like that. So this example is actually a bit of a false positive because this is you can see it's a public key, so it's not a big issue if I've got it in my repo, and it's a Red Hat network public key, but it can also find private keys and things like that as well. There's also Git Rob. This is a tool that was written by someone on the SoundCloud security team. And what this will do is it's basically kind of like a pen testing tool for your GitHub organization, either your private GitHub Enterprise setup or your public GitHub.com kind of setup. So what this will do is it will basically point it at an organization or a user. It will clone as much as it can, and the idea is you give this kind of like a pen test records to do this, and it will look through and find anything that looks like it could be secrets or anything that could be leaked. So in the blog post, he talked about how he ran this on GitHub.com just to find this stuff, and he found this is someone's .env file. You can see there's like they're obviously using a chatbot, and using Campfire as well. And you can see that there's just raw passwords and API keys and even URLs and stuff like that. So bad things happen. And if you want to keep it super simple to something like this, so this is just a one-line grep that will just go through, look for anything that refers to API and key, username, mail, Gmail, and that kind of stuff. And yeah, this is obviously, again, way more crude, and it's going to find a bunch of documentation examples as well. And one of the things that kind of comes up the most, I think, is that especially when we talk about moving security left, having a build pipeline to detect some of this stuff is probably the easiest way of finding this. So either having a CI job called detect creds or something like that does some of the tools we just used before, or even something that I found out recently called Danger, which is really cool. So what Danger does is it's basically part of a kind of a more pull request workflow. What you do is you make a Danger file, kind of like a Jenkins file, where you kind of configure what you want your repo to stop. So in this example, these are more kind of generic. These are not security specific. So it's saying if you make a change, make sure the change log has been updated. And what this will do is just like something like Hound or any sort of like code coverage tool, it will post a comment into the pull request. And it will even do things like @tag security team. And this example. So if you've heard of Sentry, which is a tool that will automatically detect errors in your logs and things like that, this is just, you might not be able to see it at the back, but what this will do is it basically looks through the Git commits that have just happened, and it will go, if file contains the certain keywords, so API or something like that, @tag the security team and say someone needs to review this manually, or maybe an automated process, or maybe just block the PR completely. So it's a good example of how to kind of make some of these processes that might be a lot more manual, where people are saying, hey, I've just made a change, can someone from security review this? You can say, well, there's no point in them reviewing a doc change, but it might be more useful if you're updating a bunch of your YAML configuration for your Ansible, your Puppet, or your Chef, or something like that. So you've removed all those plain text passwords, but you still need them, right? Because one of the key areas of a secret is it is required otherwise. So in this case, you might get rid of a bunch of stuff you don't need anymore, but you also need to make sure that the stuff that you do need is actually kept secret. And how do you do that? It's generally going to be encryption directly or some sort of secret server. So depending on what kind of infrastructure tool you're using, obviously, again, I'm going to focus on Puppet here. There should be some sort of separate data layer, and someone has probably come up with some way of encrypting that separate data layer as well. So Puppet uses what's known as Hira, so it's just a YAML configuration. Or by default, it's YAML or JSON. So in this example, I've got a bunch of configuration for a GitLab server. Unfortunately, you can see we've got unencrypted password in there, and that's very bad. So bad, plain text, someone's GitLab LDAP password 123. What's way better? You encrypt it, and you end up with something like this. So this is asymmetrical encryption. So you keep your secret keys on the Puppet master. Then every time it fetches a catalog, it sends the decrypted version down to the agent. And there's some more complicated things you can do, which I actually talk about at a talk at PuppetConf. If you want to know more about Puppet specifically, come ask me. But I'm going to try and focus and keep it general here as well. So that's Hira YAML, and it was built exactly for this use case. You want the ability to have a single place where you can get all your Puppet code, and it means that you can see diffs and you can see these changes without having to worry about people getting a clone of your code and being able to see all your passwords and things like that. So this is a kind of good thought exercise that I use when I'm talking about customers who are worried about kind of secrets and passwords and things like that, is that theoretically you should be able to open source most of your code without any sort of security issues. At least you become more generic, more modular parts of your code rather than your kind of core infrastructure. And this is actually a tenet of 12-factor apps. So who knows the kind of 12-factor app pattern here? A few hands there. Oh, there's a few hands there. So basically, it's a pattern that's designed around making kind of small, contained, kind of microservice-y applications. Has a bunch of rules around how you should configure those applications to make it easier for both dev and ops. But the key part is the litmus test is that if this is basically what you just said, if you can release your application at any time and there's no security issues, because you shouldn't just have passwords hard-coded in there. It should be pulling from a data layer that's kept separate from the main code repository. So a pretty good example of this, GDS, the Government Digital Service. Who here is from the UK? I think I heard a few British accents. There you go, Superland. So if you've registered to vote recently, gov.uk/register-vote, we've had a fair few in the last couple of years. All of that is run with Puppet behind the scenes. It's all CI. The DDS team do really cool stuff. So at GDS, they have what's known as the Digital Service Standard, which is basically rules for each government project that happens. And one of the cooler part of the rules is the thing that any code that's written has to be made open source at some point. Because technically, code that's being written in pursuit of government aims is taxpayer code. So if this is something that someone could use, it's technically our property in terms of taxpayers, so let's make it open source. So that's actually one of the key points. You need to make sure that it's all open and reusable. You need to publish it under an appropriate license. And then any time where you don't make something open source, you have to give a justification why. So gov.uk itself is run on Puppet, and their Puppet code wasn't released publicly. They had some modules on the Forge. They had blog posts about what they did. But the ability to run gov.uk in one kind of repo was not public. And they said one of the problems with that was that they did have unencrypted, they did have plain text passwords and secrets in their Git repo, so they couldn't release it. And in their blog post where they talk about it, they actually specifically mention the 12-factor app and saying we couldn't do it because we'd compromise security. So first thing they did was this is kind of similar to the kind of brute force detection of secrets we were talking about before. So this will just go through, and this is a ZSH function, and it will just go through and sort anything that looks vaguely secrety. So it's similar to what we were doing with Trufflehog and GetLeaks before. And one of the key things that people forget is that it's not just the code that can leak secrets. People have a tendency to leave secrety information in Git commits as well. So hopefully no one's ever done anything like this, but it's possible that you might have done something like this. So generally, again, you want to abstract things out. If you're going to talk about something like, this was a huge security issue that we had, so I had to fix this change, it's better to give the context to a link to like a Confluence page or a Jira ticket or something like that. So if the Git repo gets leaked, and then as long as that thing is not publicly accessible, then it's a lot easier to do that kind of stuff. And again, this is just a nice one-liner. This will go through your Git commits, and you can basically sort them through uniquely and find anything, again, that looks like a password. So by the end of it, the Puppet code that powers DDS is actually fully open and available. You can actually see it at github.com/alphagov/govuk-puppet. You can even run your own local instance. You won't be able to talk to anything because it's just the infrastructure, but you can at least play around with it and see that stuff. And they talked about, this is also a really good use case if you're interested in open sourcing some of your infrastructure as code at your company, either as individual units or even the whole thing if you're more open to that kind of stuff. Cool. So what existing parts of the DevOps toolchain can you use to make secrets more manageable? So the most basic level is going to be pure command line encryption, so GPG, PGP. And this stuff isn't super easy to use. One of the big complaints that people have about security when you're a noob with this kind of stuff is that a lot of the time the UX isn't great because these tools are designed to be very hardened. So they don't normally have GUIs. If they do, the GUI is often seen, it's not super well maintained. And there's a big trend right now that companies are basically rewriting a bunch of security tooling in Go and then kind of releasing it publicly. And then people are like, oh, cool, I'll use this. And it's never really been audited other than the fact it's being used by some big, cool company. So it's a bit of a kind of, your mileage may vary on that kind of stuff. So obvious examples, GTP. Mozilla has a tool called SOPs that does some of this, and it tries to make the process of rotating the keys a lot easier. Shopify has eJSON, which is basically the same as eYAML, but more, it's not tied specifically to Puppet. You just have a key, you encrypt values in JSON, and then the application uses the key to unencrypt them at runtime. So secret servers. So why do you want to use a secret server? As I said, the UX on most kind of command line tooling isn't great. You have things like access control lists and policies. One of the key things is the ability to audit who is using this stuff. Because if you have a key, you don't really know if it's being used in bad ways unless you specifically go to everyone's machine and look at it. Whereas if you're using a secret server, you could be like, we're getting a lot of IP bounces from some random country that we don't operate in. We should probably go investigate that. So there's a bunch of secret servers out there that you can use. Supportability is good. Again, the big thing about security is you don't want to build something yourself and then find out it's super unsecure later on. So a bunch of examples out there: Vault, Conjure, Keywiz, Confidant, CyberArk. Vault is probably best in show. I was recently at Hashi Days London, and I did the Vault training the day afterwards. And yeah, there's a bunch of really cool stuff you can do with that. And some of it even moves some of the secret management away from your config management and into Vault itself. So things like having an endpoint where it will give you a read-only credential for a database that only lasts for 30 minutes is a lot easier than having your application have a one-time username and password that just gets used all the time. If you can use leasing, it's a lot easier to manage that stuff. And it's a lot easier to prove to your auditors, like, oh, well, you can only get a password and username for this account for 30 minutes or an hour or a week or something like that. And the other thing you can do is basically pull all of the kind of secret management directly into your cloud provider itself. So Amazon has KMS, GCE recently added KMS, Azure has what's known as Key Vault, OpenStack has a tool called Barbican, which ironically is set up using Puppet, so there's a kind of weird chicken and egg situation there. But a lot of the tooling we talked about previously ties into tools like KMS, and a lot of this is actually making it so you don't have to worry about secret management too much, because if you have IAM rules that say you can only get this secret if your server matches this particular VPC, then you don't have to worry too much about secrets being leaked, because it'll only work within your AWS instance. So there's actually a plugin for eYAML that uses KMS, so then the machines, you don't have to worry about managing the secret token, or even managing the AWS API credentials, because the machine IAM rules are enough. It will just go, I need to find out what the Postgres password is for my machine, and it says, cool, you're in the right VPC group, I'm going to give you that immediately. And one thing that's kind of interesting to talk about is VCS-based encryption. So this used to be one of the main ways that people did this, and the kind of free ones I see repeated a lot are Transcrypt, Gitcrypt, and Blackbox. And these were all actual examples of ways of managing secrets within actual Puppet repositories at first. So Blackbox was made by Stack Overflow to store their passwords. This is before eYAML exists. Wikimedia uses Puppet to set up most of their tooling, and they use Gitcrypt for that kind of stuff. And there's a really good talk, so you can get really deep down into this stuff. It uses the Git attributes part of Git, but the problem with this is you don't get to see diffs in changes. You're actually encrypting binary files and then unencrypting them as it runs. So it means that it's a lot harder to track changes because all you know is that one file changed from foo to bar, but you don't know which particular secrets get done in. So it's something that's quite good on the low level, but it's a lot harder to maintain operationally. So the hardest part, and the part that people are probably most interested in, is how do you actually detect when things get leaked? And yeah, how to keep your head when everyone else is losing theirs. So first, who here has a procedure or has a rough idea of what procedure they would do if someone came up to it and said, quick, I accidentally pushed our AWS credentials to github.com, and you need to help me and figure it out. Who has a procedure to actually solve that problem? Okay, a few hands. So I would say go out there and do that right now. Because that's the biggest thing, is you need to know what you're going to do. If you don't know what to do when something goes wrong before it goes wrong, it's going to be way worse when it actually goes wrong. So the most generic process you can do, roll new keys for everything you can and reset passwords. You need to make sure that if you don't already have good monitoring or being able to observe strange behavior, that you either enable it or just increase it. The easy thing to do, the whole pets versus livestock argument, destroy as many machines as you can. So if they're containers, respin them up with new credentials. And lastly, yeah, keep track of the actions that you're doing for the post-mortem, because you need to. We talked a lot about post-mortems today. You need to be able to figure out why this happened and how to stop it from happening in the future. So there's a few tools out there you can actually use to proactively detect some of this stuff. So Netflix made a tool called Scumbler. So Netflix, their use case was primarily for things like detecting when someone on Twitter says, I'm super cool, elite, hacking kid, I'm going to DDoS Netflix right now. So they basically have this running in their, within the sort of Netflix security team, and then they have tweets that will come up and say, I'm going to DDoS Netflix or something like that. And then that gets actioned and someone can go, I'm going to go find out if that's a real threat or just some random kid on the internet. But one of the coolest things you can do in this screenshot is that it will actually tie into a bunch of tools like github.com, Pastebin, Gists, and things like that. And you can basically have a proactive search that will go out and look for things. So in this example, they're looking for some of the things that we were talking about before. So ID RSA is the default name for an SSH key that gets generated. So you're looking to make sure no one's accidentally pushed that up there. You're looking for begin RSA key. They actually also directly refer to some Java unsafe terms for code. So you want to make sure that no one's accidentally pushed unsafe Java stuff as well. So this is a mixture of AppSec and infrastructure secrets leaking kind of there. And this also ties into things like Pastebin, which people often post leaked credentials to. So you can kind of proactively look for when leaks happen. So there used to be a website called getleaks.com that was basically going to do this as a service. But people kind of question the ethics of a website that basically, for free, would let you look for leaked credentials on the internet. So I think it briefly appeared for like 2 weeks in February. There's a big outcry, and then it was gone. But there is, you could build something like this yourself. That's what Scumbler was basically used for. But ultimately, we talked a lot about the common ones like AWS keys and RSA keys and stuff like that. But what if you're not using AWS? What if you're using something else? What if you have your own way of rolling passwords? There's no silver bullet to detect leak secrets. There's common stuff you can look for, like at yourcompanyname.com on GitHub to make sure no one accidentally pushes usernames and passwords. But there's no 100% effective way of detecting some of this stuff. So we kind of talked about this a lot. I mean, this is a common theme in DevOps, is the only real solution is good monitoring and good metrics and the ability to detect this stuff before it becomes a problem, or automatically detecting it when it is a problem. So it's all about outliers and anomalies, because it's all well and good having metrics to say, here's how many people are SSHing into our systems, but you need to know, well, this one's a bit weird, it's coming from an IP that we don't expect, or it's happening at 2 in the morning, and we have a team that's based in the GMT time zone or something like that. But just like anything else, it's largely people and process problem. You need to make sure that there are ways of being able to detect this stuff, and when you know that you've leaked, you actually have a run book of what you're going to do when it happens as well. Because it's better to be prepared, better to have it and not need it than need it and not have it. So who here has host intrusion detection systems actively running on their infrastructure right now? A few hands out there. So there's a bunch of tools out there. One of the famous ones, Even Tripwire can be categorized as this, but things like OSSec, it will look for suspicious DNS activity and SSH activity, and you can plug that into things like Kibana and have alerts and logs come up. So definitely if you're in like a high security kind of team, or if you're worried about this kind of stuff, I'd look into getting HIDS installed. And yeah, this should be the kind of workflow that happens, is that you have credentials and they get leaked. That unusual activity should either be actively seen as part of review, or it should be automatically detected as part of your monitoring. And your blue team goes out, finds out what happened and fixes it, and then makes sure that you actually have a retrospective to find out how do you stop this from happening in the future. And yeah, we've already talked about this a lot today. The idea of shifting security left. We want to make sure that we're not in the world of throwing security over the wall. We want to make sure that we're actually, actively trying to fix this stuff before it becomes a problem. Because everyone's seen the chart of how difficult it is to fix a bug the closer you are to production, and it's like down here when you're writing the code and here when it's actually live. Imagine that, but for security things. It's ways to fix it before it becomes a problem. Yeah, there's a good quote about shifting left there. Basically, make sure that you've moved your design security into your design rather than into the later steps. So how can we proactively do this? So game days and internal evil attempt teams. Who here has game days for security, or game days in general, and maybe not for security? A few hands up. So yeah, basically that's just a bunch of people go into a room, and it's kind of like the old days of when the NSA were versus the Navy, and they'd say, try and hack into our systems, and they'd say, we're already in, So. There's actually a quite funny story. I'd recommend there's a really good book called what is it? It's the history of cyber warfare, and they talk about how when the Navy first installed their intrusion detection systems, they kept going off and they were saying, oh, this is faulty. This is a brand new system, and it's saying that we've been cracked. And then the NSA had to say to them, like, yes, it's because we've been on your systems for the last year preparing for this red team event. So. And yeah, so one of the other ways of doing it is dedicated security stories for sprints, if you're using a kind of sprint methodology. They're often called evil users or misuse stories, use cases. And OWASP actually has a really good guideline on this, talking about threat modeling and how you do that. There's a really good book called just Threat Modeling, and it kind of talks about how you can build these kind of ideas into your planning. And most of the kind of information you read about this will be very AppSec focused. But most of it kind of translates into the infrastructure, the code world pretty easily because it's the same concepts, right? Embedded security team members. So, you have someone as part of the review, looks at your security stuff and says, I think this, wave a red flag and say, I think this is bad. And lastly, pen tests, either internal or external. It's always good to have a fresh set of eyes look at stuff and make sure they're a good, reputable company rather than the places that just fire off, generic DDoS tools against your infrastructure. So this is a really good game day we often talk about with Puppet people. We talk about agent spoofing. So we say, give someone a generic dev agent and find out how much information they can get from there. So if you're using plain text passwords, then you'll be able to, there's a kind of escalation there. From looking at one plain text password, can you figure out how to get to the next step? Can you get an API key from there? How bad can it get? Do you leave SSH keys lying around and that kind of stuff? So that's one good example of agent spoofing. And the next one is laptop theft. So who here has a company policy that all machines have to be full disk encrypted at all times? Cool. That should be everyone's hands. Can you detect if someone's not got full disk encryption on their systems? Raise your hand if you can. Okay. Well, they say, so that's one of the key things is it's easy to say that. It's not, depending on, if your developers have full sudo and root to their systems, they can just turn that off. So it's one thing you need to detect. So the idea here is this is a good kind of game day you can do. You find someone's laptop, or you make a kind of dummy laptop with the kind of base configuration you've set on your systems. You then give it to someone and say how much damage you can do, and then if you kind of do it in secret, can people on your team detect this damage before it actually, either when it's in the early stages or before it gets really bad? Because that's one of the big things that's happened with a lot of leak credential situations recently is people don't detect them until months after the fact. That's really bad. Like, if you detect them in real time, that's bad, because you'll be preventing them before they happen. But if you don't even know it's happened until a year after the fact, there are situations where people have cracked, people have gotten AWS keys, given themselves AIM credentials, waited until things calm down, or the holiday period, maybe Christmas or something like that, and then they hit them for everything they've got, knowing that they can't respond as well because people will be on holiday. And yeah, the key thing here is how long does it take to get detected if you do something bad? So what have we learned? Leaking things is bad. Hopefully that it wasn't something that you had to be taught. The consequences can be super dire. So start off by going through your infrastructure as code and removing plain text secrets. So if I'm here next year, I want to be able to ask and say who's got plain text secrets in their infrastructure. There should be no hands, or at least a very small amount of hands. Make sure that that data is actually kept secret after the fact, either using direct encryption or using a secret server. But Vault, as I said, is probably one of the best in play. If people have other opinions, then feel free to come talk to me. Vault is the one I've used the most. And then make sure that those secrets are kept secret. So proactively detect if things get leaked. Make sure that you have some sort of security as part of your workflow. CI pipelines, things like Danger, things like Giddy leaks and Trufflehog to detect when this stuff kind of goes through as part of your CI pipeline. Know what to do when things go wrong. So have a run book, have kind of dedicated ways of doing that. Have game days where you can kind of do this in not in production, I guess is the best way of putting it, and finding out what happens when these scenarios happen. And yeah, this is something that's probably going to come up more and more in more DevOps days in the future, is move security left, make sure that you're not siloing your security team and throwing it over the wall to them afterwards. So if you want to know more, here's a bunch of links. Obviously, when I send the slides out, I don't expect people to write these down from here. One of the cool things out there, the last one there, is a gist that someone wrote that basically compares pretty much all the secret management tools out there, their advantages and disadvantages. That contains a bunch of the custom-written secret tools that people have written at companies that I didn't list because your mileage may vary on those. But there's a really good paper. I think it was people from IBM basically talked about being able to detect this stuff and talk about some of the use cases and how bad it can be. The secrets and liabilities kind of, again, go through the why secret leaking is bad and what you can do about it. The talk I gave earlier on by Daniel Sommerfield, and lastly, the talk by Noah Kantowitz. It's mainly focused on more chef tooling because he's a chef person, but he also talks about things like hierarchy YAML, and even goes deep into the difference between asymmetrical and symmetrical passwords and things like that. Cool, that's it. So, any questions?
My question would be, what do you think about proactive key rotation, part of the training exercise, so that the people know what to do when it actually hits?
Yeah, exactly. Yeah, that's a great thing to do. That's one thing that happens is, I can't remember who wrote it, I'm trying to remember who wrote it, but there's a really good article about the average amount of keys at a company and how many keys are left on servers. And like, I don't know, someone who isn't me, who here theoretically has tried to SSH or log into a system for a company they've not worked for years, 2 or 3 years. See, yeah, I mean, everyone's done it. Like, there have been situations where I pull down a repo and I still can, even when you remove someone's GitHub user from organizations, I think sometimes the key can hang around and you can still clone and push up even without the username directly being there. So actually having a way of rotating those keys and knowing how to rotate them is a really good thing to do. Again, you want to make sure that you know how to do this and you know what to do before you need to know it, than it is to say, oh crap, one of our sysadmins has gone rogue and he's smashing all this stuff up. We need to figure out how to rotate keys. Okay, well, here's the here's the SSHD manual. I'm going to read through and figure out how we can stop him from doing this stuff. So.
Any more questions? No?
Cool. Thanks, everyone.
Thank you very much.